They are fun. Yes, they are. But I'm not happy with the values that they've chosen a little bit. Because do you know what cos of pi over 4 is? Yes. So for A, you could solve A just directly from your pi plate. And that's not what they're wanting in this question. Okay? They say write it as a single trig ratio first and then solve. Okay? But if you were just asked to evaluate part A, you could say, I know cos of pi over 4 is root 2 over 2. So cos squared of pi over 4 would be root 2 over 2 squared. But if I first had to write it as a single trig ratio, they want you to recognize, and this is why you have to have these things mostly memorized. Do we have an identity that has cos squared minus sine squared? Yes, it's cos 2 theta. So our theta is pi over 4, and we could write this as cos 2 times pi over 4. And cos 2 times pi over 4 can be simplified to be cos of pi over 2. Still on our unit circle, what is cos of pi over 2? 0. And now we've evaluated it. So yes, we could have figured out root 2 over 2 and squared it. And we could have figured out sine of pi over 4 was root 2 over 2 and squared it, and then subtracted those. And because it's the same number subtracted from itself, you would get 0 that way as well. I think what they want to show you in this is if you recognize the identity, your math is quicker, especially in part B. Because in part B, if you did tan of pi over 6 and got root 3 over 3, you'd have a root 3 over 3 on the top, and you'd have a root 3 over 3 squared on the bottom, and you would just have a lot of simplifying to do with fractions inside of fractions. Doable, but a little bit tedious. But does this match up as one of our formulas? Yes. That's our double angle for tan. So we could write B as equal to tan of 2 times pi over 6. Yes? Oh yeah, it doesn't match up. Thank you. Thank you, thank you. So the formula has 1 minus, it should look like this, right? Good observation. That's what the formula should look like, and ours has tan squared pi over 6 minus 1. How do I switch those around to make it look like this? I have to factor out a negative. Now, with a fraction, when you have a negative, so now that negative's on the bottom of my fraction, right? If I have a negative on the bottom of the fraction, it's the same as having a negative out in front of the fraction or a negative with the top of the fraction. In this case, I took a negative out on the bottom. I'm going to think of this as a negative out in front. Can you see why that's going to be helpful? Because now inside the brackets matches up perfectly with the formula. And so this becomes negative. What's that? How does that match up with the formula? On the formula up there, here's our alpha, right? And inside the brackets, it matches up. Okay? Yes? I did rewrite the same thing, but I put a negative outside so that here, inside, I can say, I can change this to tan 2 times pi over 6. And 2 times pi over 6 can be simplified to tan of pi over 3. Tan of pi over 3 is root 3, so we get a final answer as negative root 3. Oops. There you go. And we are going to add a part C. Part C, there are two methods of doing part C. And if I were marking one method, I would say the question would be out of 2 marks. And if I was marking the other method, then the question should be out of 8 marks, or maybe 10 marks. Okay? So one method is a lot easier than the other method. Yes? They would have to, yes. If you had an 8-mark question that you did in a 2-mark way, they would have to give you the full marks. That happened on a grade 11 exam a number of years ago. You remember learning the cosine law in grade 11? So the question was, find the area of the following triangle. And the triangle gave all 3 sides. So the question was out of 5 marks because they imagined you using the cosine law to find one of the angles. And that was worth 3 marks. And then using your area formula with sine, where it uses the angle and the 2 sides beside 1/2 AB sine C to find the area, and that was worth the other 2 marks. Now, I had taught my class a formula for area that just used the 3 sides. And if they remembered the formula, they just had to write it in, plug it in, get their answer in like 2 steps. And so some of my students remembered that and did the 5-mark question in the 2-mark way, but they still got full marks. Anyways, part C. So there's 2 different ways this could be done. And this is, again, part of what you do in any class is you teach yourself triggers. We talked about that in that first question. I said, once you get up to here, I'm hoping you think, I have to draw a triangle. You teach yourself certain triggers to recognize things that trigger you to do something. Okay? What happens sometimes in questions is a question has 2 triggers. And if you pull the wrong one, you end up doing the 10-mark way. If you recognize the other one, you can do it quicker.
Sorry for interrupting.
Hello?
I'm supposed to let you know that the chicken guy is here.
So here is the question. Evaluate 2 sine pi over 12 cos pi over 12. And the stronger trigger for you guys will be, this is a pi over 12 question. You will get triggered to think that because what do you see? Pi over 12. Okay? And how did we do pi over 12 questions? Well, we found an alpha plus a beta and did the big expansion and simplified, and we got a root 6 plus a root 4 over 2, or something like that. Or, yes, a root 6 and a root 2 over 4. That's right. And we figured that out. And we would have to do that for sine, and then you'd have to do another alpha plus beta for cos. And that's why that would be very big. But that will be your stronger trigger. Your weaker trigger is to recognize that we have 2 sine cos of the same angle. And that's one of our double angle identities. That's the right hand of this formula right up here. And if you use that formula, then this just becomes sine 2 times pi over 12. And 2 times pi over 12 reduces to sine of pi over 6, which is on our pi plate, and it's equal to? 1/2. Not enough. Close, almost rhymed.